Hello, chemistry students. Today we will be performing our solubility experiment. In parts A and B of this experiment, we'll investigate the solubility of various substances in different solvents. In part C, we'll look at miscible and immiscible pairs of liquids. In part D, we'll investigate the solubility of organic acids and bases. And in part E, we'll apply the principles learned in parts A through D. Let's get started. We will now investigate the solubility of benzophenone in 3 different solvents. So we've transferred 40 milligrams of benzophenone into 4 different test tubes. We have our control test tube, which we will put no solvent in. We have our test tube for water, our test tube for methanol, and our test tube for hexane. And we have our deionized water here, our methanol, and our hexane. So what we're going to do is we're going to add 1 milliliter of deionized water to our test tube for water with our benzophenone in it, and we're going to stir using a micro spatula for 60 seconds. And then we will compare the amount of solid benzophenone remaining in our test tube with water to our control test tube. And we will repeat this process for methanol and hexane as well. Let's get started. So we're adding 1 milliliter of deionized water to our test tube for deionized water and the benzophenone. And then we're going to stir by swirling with our micro spatula for 60 seconds. Okay, it's been 60 seconds, so we'll remove the micro spatula. And we'll compare the amount of benzophenone remaining in our water to our control test tube. So we have our control and our water. And this is the amount of benzophenone remaining in our 2 test tubes. Now, a lot of the benzophenone is floating on the top of our water. But you should be able to determine how soluble our benzophenone is in the water. Again, this is our control test tube, and this is our benzophenone in the water. Okay, now we're going to repeat this process with methanol. So we'll take 1 milliliter of methanol and add it to our test tube with our benzophenone. And then we will stir for 1 minute with our micro spatula. You can see that after about 30 seconds or so, here's our control. So we have our control and our methanol. And here's the amount of solid benzophenone remaining in our test tube with methanol compared to our control. Okay, now we're going to repeat this procedure 1 more time using hexane. So we're going to take 1 milliliter of hexane and transfer it to our test tube with the benzophenone. And we'll start mixing or twirling our microspatula in our test tube with our benzophenone and our hexane. So it's been about 1 minute or 60 seconds, so we're going to remove the microspatula and we'll compare the amount of solid benzophenone remaining in our hexane compared to our control. So we have our test tube, our control test tube, and our test tube with the hexane. And here's our control test tube and our test tube with the hexane in it. And you can see that we do still have some solid benzophenone remaining in our test tube with the hexane. You should now be able to draw some conclusions about the solubility of benzophenone in each of our three solvents: our deionized water, our methanol, and our hexane. We're next going to repeat this procedure and investigate the solubility of oxalic acid. So we have our oxalic acid here, and we've added 40 milligrams to 4 separate test tubes. We have a test tube for our control, for water, for methanol, and for hexane. So we'll start with our deionized water. And we'll add 1 milliliter of deionized water. And then we'll swirl our microspatula to mix. And it's been about 10 seconds. And we'll compare to our control. So we have our control test tube and our test tube with water. And you can see the oxalic acid in our control test tube compared to our test tube with the deionized water. We'll now repeat this procedure using methanol. So add 1 milliliter of methanol to our 40 milligrams of oxalic acid, and we'll swirl with our microspatula. And it's been about 10 seconds of swirling, and we'll compare to our control test tube. So we have our control test tube and our test tube with methanol. And you can see the oxalic acid in our control test tube and what is left remaining in our test tube with the methanol. We'll now move on to hexane. So we'll add 1 milliliter of hexane to our test tube with our oxalic acid. And then we'll twirl our microspatula. So it's been about 60 seconds. So we'll remove the microspatula and we'll compare the oxalic acid remaining in our test tube with hexane to our control test tube. So our control test tube and our test tube with the oxalic acid and the hexane. You should now be able to draw conclusions about the solubility of oxalic acid in deionized water, methanol, and hexane. We're going to repeat this procedure one last time to investigate the solubility of biphenyl. So we've added 40 milligrams of biphenyl to 4 different test tubes for our control, our water, our methanol, and our hexane. So we'll start with deionized water. We're going to add 1 milliliter of deionized water to our 40 milligrams of biphenyl. Then we're going to twirl a microspatula inside of our test tube for 60 seconds. So it's been about 60 seconds, so we're going to remove our microspatula and we'll compare the amount of solid biphenyl remaining in our test tube with water to our control. So these are our 2 test tubes. This is our control, and this is our test tube with the biphenyl and the deionized water. Now you can see most of our biphenyl is floating on top of the deionized water. Okay, now we're going to repeat this procedure using methanol. So we'll add 1 milliliter of methanol to our 40 milligrams of biphenyl. And we'll twirl our microspatula inside of our test tube with our biphenyl and our methanol. So it's been about 60 seconds. So we'll remove our microspatula and we'll compare the amount of solid biphenyl remaining in our test tube with methanol compared to our control. So we have our control here and our test tube with the methanol and the biphenyl. And you can see that there is some solid biphenyl remaining in our test tube with the methanol. Our control and methanol. Okay, now we're going to repeat this procedure one last time using hexane. So we'll take 1 milliliter of hexane and add it to our test tube with our biphenyl. And then we'll twirl a microspatula for 60. Okay, so it's been about 30 seconds. We're going to remove the microspatula and we'll compare the solid biphenyl remaining in our hexane compared to our control. So we have our control here and our test tube with our biphenyl and the hexane. Okay, you should now be able to draw conclusions about the solubility of biphenyl in our deionized water, our methanol, and our hexane. This concludes part A of this experiment. In part B of this experiment, we're going to look at the solubility of different alcohols in water and hexane, and we're going to start with water. So I've already added 1 milliliter of water to 3 separate test tubes, and to each test tube, we're going to add dropwise a different alcohol. So we'll add 1 octanol to a test tube. We'll add 1 butanol to a test tube. And we'll add methanol dropwise to a test tube. The first alcohol that we're going to look at is 1 octanol, and we're going to add it to water dropwise. And we're going to add 20 drops of 1 octanol to our water. We'll now add 20 drops of 1 octanol to our deionized water. We've now added 20 drops of our 1 octanol to our deionized water. The next alcohol that we're going to look at is 1 butanol in deionized water. We'll now add 20 drops of 1 butanol to deionized water. And we've now added 20 drops of 1 butanol to our deionized water. The next alcohol that we're going to look at is methanol in deionized water. We'll now add 20 drops of methanol to our deionized water. We've now added 20 drops of methanol to our deionized water. We're now going to look at the solubility of our 3 alcohols in hexane. So I've already added 1 milliliter of hexane to 3 separate test tubes. We'll first look at the solubility of 1 octanol in our hexane. So we'll now add 1 octanol dropwise to our hexane. We've now added 20 drops of 1 octanol to our hexane. We'll now look at 1 butanol in hexane. We'll now add 20 drops of 1 butanol to our hexane. We've now added 20 drops of 1 butanol to our hexane. We'll now look at the solubility of methanol in our hexane. We'll now add 20 drops of methanol to our hexane. And we've now added 20 drops of methanol to our hexane. This concludes part B of this experiment. For part C of this experiment, we're going to be determining whether two liquids are miscible or immiscible. Miscible pairs of liquids form one layer, and immiscible pairs of liquids form two layers. The first two liquids that we're going to be looking at are deionized water and ethanol. We'll add 1 milliliter of deionized water and 1 milliliter of ethanol to a test tube and look at whether the liquids are miscible or immiscible. I've already added 1 milliliter of deionized water to our test tube. We're now going to add 1 milliliter of ethanol. So this first test tube contains 1 milliliter of deionized water and 1 milliliter of ethanol. The second pair of liquids that we'll be looking at is deionized water and diethyl ether. I've already added 1 milliliter of water to our test tube, so we'll now add 1 milliliter of diethyl ether. We've now added 1 milliliter of water and 1 milliliter of diethyl ether to our test tube. The next pair of liquids that we'll look at is deionized water and methylene chloride. I've already added 1 milliliter of water. We'll now add 1 milliliter of methylene chloride. We've now added 1 milliliter of water and 1 milliliter of methylene chloride. The next pair of liquids that we'll look at is deionized water and hexane. I've already added 1 milliliter of water to our test tube. We'll now add 1 milliliter of hexane. We've now added 1 milliliter of water and 1 milliliter of hexane to our test tube. The last pair of liquids that we will look at is methylene chloride and hexane. I've already added 1 milliliter of methylene chloride. We'll now add 1 milliliter of hexane. We've now added 1 milliliter of methylene chloride and 1 milliliter of hexane to our test tube. You should now be able to determine whether each pair of our liquids are miscible or immiscible. This concludes part C of this experiment. For part D of this experiment, we're going to look at the solubility of organic acids and bases. And the first thing we need to do is add 30 milligrams of benzoic acid to 3 separate test tubes. I've added 30 milligrams of benzoic acid to 3 separate test tubes. And what we're going to do now is we're going to add 1 milliliter of deionized water to our first test tube, 1 milliliter of 1 molar sodium hydroxide to our second test tube, and 1 milliliter of 1 molar hydrochloric acid to our third test tube. Once we add each solution to the test tube, we'll use a micro spatula to stir the mixture of the benzoic acid and the solution and determine whether the benzoic acid is soluble or insoluble in each of these three solutions. We're going to start with deionized water. So we'll add 1 milliliter of deionized water to our first test tube with the benzoic acid, and then we'll use a micro spatula to stir for 20 seconds. We've now stirred our water and benzoic acid mixture for 20 seconds. So we're going to move on, and we're going to add 1 milliliter of our 1 molar sodium hydroxide solution to our second test tube. And we'll stir the mixture inside our second test tube for 20 seconds. We've now stirred our benzoic acid and 1 molar sodium hydroxide mixture for 20 seconds. We'll now move on to the third test tube. And to the third test tube, we'll add 1 milliliter of 1 molar hydrochloric acid. And then we'll stir our mixture of our benzoic acid and 1 molar hydrochloric acid for 20 seconds. We've now stirred our mixture of benzoic acid and 1 molar hydrochloric acid for 20 seconds. You should now be able to determine the solubility of benzoic acid in deionized water, 1 molar sodium hydroxide, and 1 molar hydrochloric acid. And what we're going to do now is we're going to add 6 molar hydrochloric acid dropwise to our test tube containing the mixture of benzoic acid and 1 molar sodium hydroxide. So we're adding dropwise 6 molar hydrochloric acid. And we're now going to add a micro spatula, and we'll check the pH of our solution inside of our test tube using pH paper to make sure that we now have an acidic solution. And you can see that our solution has become acidic in pH. And you can also see what that has done to the solubility of our benzoic acid inside our mixture. We're next going to repeat this procedure, but use ethyl 4-aminobenzoate as our solid compound instead of the benzoic acid. So we first need to measure out 30 milligrams of ethyl 4-aminobenzoate into 3 separate test tubes. I've added 30 milligrams of ethyl 4-aminobenzoate to each of our 3 test tubes. And we'll now add 1 milliliter of deionized water to our first test tube. And use a micro spatula to stir the mixture of our ethyl 4-aminobenzoate and our deionized water for 20 seconds. We've now stirred our mixture of ethyl 4-aminobenzoate and water for 20 seconds. So next, we'll add 1 milliliter of our 1 molar sodium hydroxide to our second test tube with the ethyl 4-aminobenzoate. And we'll stir our mixture for 20 seconds. We've now stirred our mixture of 1 molar sodium hydroxide and ethyl 4-aminobenzoate for 20 seconds. We'll next move on and add 1 milliliter of 1 molar hydrochloric acid to our third test tube containing the 30 milligrams of ethyl 4-aminobenzoate. And we'll use a micro spatula to stir our mixture of hydrochloric acid and ethyl 4-aminobenzoate for 20 seconds. We've now stirred our 1 molar hydrochloric acid and ethyl 4-aminobenzoate mixture for 20 seconds. We're next going to add dropwise 6 molar sodium hydroxide to our third test tube containing the 1 molar hydrochloric acid and ethyl 4-aminobenzoate mixture. We'll now add 6 molar sodium hydroxide to our 1 molar hydrochloric acid and ethyl 4-aminobenzoate mixture. And we'll mix our solution, and then we'll check the pH of our solution using pH paper. And you can see that our solution is now basic. And this is the solubility of our ethyl 4-aminobenzoate once we've made the solution basic using 6 molar sodium hydroxide. This concludes part D of this experiment. Part E of this experiment is divided into 3 sections, and for section 1, we're going to look and determine whether 2 liquids are miscible or immiscible, and you'll need to explain the results. So the liquids that we're going to be looking at are deionized water and acetone. That's our first pair of liquids. And our second pair of liquids is acetone and hexane. So I'm going to add 2 milliliters of deionized water to our first test tube. And I'm also going to add 2 milliliters of acetone to our first test tube. And we'll now look to see whether our 2 liquids are miscible or immiscible. So we've added 2 milliliters of deionized water and 2 milliliters of acetone to our test tube, and you'll need to determine whether the 2 liquids are miscible or immiscible and explain why. We're next going to add 2 milliliters of acetone to our second test tube. And we're also going to add 2 milliliters of hexane to our second test tube. We've added 2 milliliters of hexane and 2 milliliters of acetone to our test tube, and you'll need to determine whether the two liquids are miscible or immiscible and explain the results. In section 2 of part E of this experiment, we've been given a test tube containing 2 immiscible solvents and an organic compound dissolved in one of those solvents. And what we've been given in our test tube is the solid salicylic acid and the liquids methylene chloride and 1 molar sodium hydroxide. And if we look at our test tube closely, we can see that we have 2 layers. We have our top layer and we have our bottom layer. Those are the 2 immiscible solvents in our test tube. You first need to predict which layer is the methylene chloride and which layer is the 1 molar sodium hydroxide. And then you'll need to justify your predictions. So what I'm going to do first is I'm going to take a Pasteur pipette and I'm going to transfer the bottom layer from our test tube to a new test tube. Once I've transferred the bottom layer to a new test tube, we can now work with these 2 layers separately to determine which layer contains the organic compound. So we have our top layer remaining in the original test tube, and our bottom layer has been transferred to a new test tube. I'm now going to take our bottom layer that we transferred into a new test tube and place it in a hot water bath. And I'll also direct a stream of air into our test tube to help evaporate off the solvent in our test tube. And while that bottom layer is evaporating from the test tube, I'm going to take our top layer, and to our top layer, I'm going to add several drops of 6 molar hydrochloric acid. And I'm going to add our 6 molar hydrochloric acid dropwise until our solution becomes acidic in pH. I'll now take a micro spatula and swirl our top layer that we've now made acidic with 6 molar hydrochloric acid, and we're going to check to make sure that it is acidic using pH paper. And you can see that we have made our top layer acidic. And that we do have our solid salicylic acid in our top layer. What we'll do next is wait for our bottom layer solvent to evaporate from the test tube in our hot water bath to confirm that there's no solid compound in our bottom layer. Our bottom layer solvent from our original test tube has now completely evaporated from the test tube that we transferred it to while in the hot water bath. And this is the result from the evaporation of that bottom layer solvent. You'll now need to explain why we performed the procedures we did in this experiment and whether the results of those procedures are consistent with your original predictions. In section 3 of part E of this experiment, we're going to determine the solubility of tetraphenyl cyclopentadienone in methanol. And we first need to transfer 25 milligrams of our tetraphenyl cyclopentadienone into a clean, dry test tube. I've transferred 25 milligrams of our tetraphenyl cyclopentadienone to our test tube. We're now going to add 1 milliliter of our methanol to our test tube with our tetraphenyl cyclopentadienone, and then we'll shake the test tube for 60 seconds. This is our mixture of tetraphenyl cyclopentadienone and methanol after 60 seconds of shaking. You need to determine whether the tetraphenyl cyclopentadienone is soluble, partially soluble, or insoluble in the methanol and explain your answer. This concludes part E of this experiment. Okay, students, you should now have a better understanding of the solubility behavior of organic compounds. This concludes our solubility experiment. Thank you for joining me for this laboratory.